All right, we're back again. Um, we're continuing with more examples on the previous lesson. So this is still series and sigma notation. So now we've got another sum to do. So we've got sigma, and then the very last term that we have here is 8. Do you see that? And where do we start? We start at 1, and our general term is 2k. And so we're going to start substituting the value 1 in the place of k, because k equals 1, and that's where we start. And we're going to end with the value 8. All right. And you would remember, if you watched the previous lesson to this one, I said that there is a formula to find out how many terms there are in this particular pattern. And so, or this series. And so the formula is this here. But I'll do that in the end. Okay, so let's have a look at what we're supposed to do here. So the first term to substitute in our general term. So this here is our general term, 2k. And then this is the first term, 1. And then 8 is our last term. Okay, so let us start with substituting the very first term, which is 1. So k equals 1. So in the place of k, we will substitute the value 1. And so they've done that for us. And then we go on to the second one. It is still 2k. So what's the number after 1? It is 2. And so we substitute 2. The very next number is 3. We substitute 3. The very first number after that is 4. We substitute the number 4. And we do 5, and then we do 6, and then we do 7. And then 8, our last term. And then I said to you in the last video again that you can choose how you want to do this. You could do it on your calculator, but definitely we want to see this step here. Don't just put everything in your calculator, because you're going to get the final answer, and we are interested in the final answer, but this step is vital. We want to see it. All right. So 2 times 1, because brackets mean multiplication. 2 times 1 is 2. 2 times 2 is 4. Times 3 is 6. Times 4 is 8. Times 5 is 10. Times 6 is 12. And then times 7 is 14. And then 16. And then you add all of those. You can use a calculator. You can do it manually. So we just interested in the final answer. All right, let's look at the next one. This one differs from the one on top, or maybe before I even go there. So the formula to find out what the number of terms is 8, the very last term, minus the very first term, plus 1. Okay, the top minus the bottom plus 1. That is the formula. Top minus bottom plus 1. That's how you get it. You don't actually have to remember it, because there it is. Okay. But anyway, let us get on to the second one. So you've got 8 at the top. You've got k equals 0. And then you've got 2k equals. Right. So the last term is 8. The very first term is 0, and then our general term is 2k. So the only thing that has changed here is where we start. Do you see that? That's the only thing. Now we start substituting the value 0, and then I'm going to do the following step, this step here. That's what I'm going to do immediately. So 2 times 0 is 0, and then we're going to substitute the value 1. 2 times 1 is 2. And then we're going to substitute the next value, which is 2. 2 times 2 is 4. And then we're going to substitute the very next number, which is 3. 2 times 3 is 6. And then we're going to do the next one. 2 times 4 is 8. Next one, 2 times 5 is 10. Next one, 2 times 6 is 12. And then next one, 2 times 7 is 14. Next one, 2 times 8 is 12. Now pay careful attention. Do you see that we end at 16 for both patterns or for both series? And then do you see that our answer is exactly the same? We've got 72 for both. What's the difference? The difference is that here we've got 9 terms in B, and in A we've got 8 terms. Why? So it is because we started number before 1, which is 0. Do you see that? And so if you start at 0, you're going to have an additional term. So remember how you get your number of terms is you say top minus bottom plus 1. So our top in B is 8, right? And our bottom in B is 0. So we take 8, subtract 0 plus 1, and that gives us 9. And so we've got 9 terms in the second one and 8 in the first one. So let's go on to C. We've got the exact same thing. What has changed now? K equals 2. All right. So if K equals 2, we're doing the exact same thing. We're substituting our values from 2, because 2 is the first term or the first number that we're supposed to be substituting into our series. And then we end at 8. See? 2, 8. 2, 8. And then you do what we've been doing all along. Take your 2, multiply by 2, you get 4. Take your 2, multiply by 3, you get 6. Take your 2, multiply by 4, you get 8. Take your 2, multiply by 5, you get 10. Take your 2, multiply by 6, you get 12. Take your 2, multiply by 7, you get 14. 2 times 8 is 16. The answer is 72. What's different? We started at 2, a number after 1. And our answer now differs. It is no longer 72, but 17. What's our number of terms? Top minus bottom plus 1. What is top? Top is 8. Bottom, 2 plus 1. So the plus 1 you'll see is always there. So that there is part of the formula for us to find the number of terms. Okay, so our answer here is 7 terms. Let's count them. 1, 2, 3, 4, 5, 6, 7. You see that? All right. And then let us have a look at the notice. Notice that the last value you substitute is not necessarily the number of terms that will be added. I'm going to read that again. Notice that the last value you substitute is not necessarily the number of terms that will be added. So in simple English, what that means is notice that the last value, which in this case is 8, is not necessarily or does not necessarily mean that we're gonna have 8 terms like in the first one. Do you see? So in the first one, the last term was 8. How many terms did we have? 8. In the second one, our last term was 8, but how many terms did we have? 9. Do you see? Our last term in the last one, which is C, is 8, but how many terms do we have? 7. Do you see what the difference is? The difference is basically this. Continue to calculate manually. You can't just assume. You definitely shouldn't assume. This is maths, right? All right. And so let's finish off this page rather. So we've got there, that's the formula. I've been saying it countless times, so it should be drilled into your head. So we've got top minus bottom plus 1. Top is N, bottom can be K, but here they have M, and so plus 1. So they're taking it from here. Okay, top is n, bottom is m, and our plus 1 is always there. Okay, so now let us look at example number 14. Determine the number of terms in each series. Determine the number of terms in the following series. Okay, so we've got B at the top, we've got 5 at the bottom, and so that's basically what we need, right? We need top, bottom, and then we're gonna add a 1. So what is our top? Our top is B for A, right? And then what is our bottom? 5. And then what are we gonna add? 1, because that's part of the formula. And so what is our answer? How many terms do we have? So B, you can't do anything to B because there's no like term for B to add or subtract. And so what is minus 5 plus 1? Minus 5 plus 1 is minus 4. So we have B minus 4 terms. That's our answer. B minus 4 terms. Okay, let's have a look at the second one. So now we've got 2n and we've got n plus 1. And so what are we going to have? Top minus bottom plus 1. Okay, let's have a look at it. Top 2n minus. That's very important. And the very important part here, guys, don't mess this up. What is the bottom? The bottom is n minus 1. It's not just, it's n plus 1. It's you have to put it into the bracket because you're subtracting the whole bottom. You're not just subtracting n, because here's why that's important. And maybe I should write this somewhere. Let's say 2n, right, minus, I'm going to show you what difference it makes for you not to put n plus 1 into brackets. Just want to show you this. Okay, so we've got the top minus, and then we've got the bottom, and then we have the plus 1, which is part of the formula. Okay, so now look at this. If we say 2n minus n, that is just n, right? 2n minus n is n, and then we've got 1 plus 1, which is a positive 2. Do you see that? That is our answer basically. N, 2n minus n, maybe let me just neaten that up. So you've got an n there, right? N minus n, because they like terms, and if you know, there's an invisible 1 in front of the n. So 2n minus n is 1n. And then 1 plus 1 is 2. Okay, so that's if you do not put it into brackets. And if you do not put it into brackets, it's going to affect what your answer is. And so if we are told that we're supposed to take the top minus the bottom, that means we need to subtract the whole bottom. The whole bottom is n plus 1. So you subtract the whole, and that's why it's in brackets. And so now what we need to do is multiply the negative into the brackets. So what is negative times a positive? Because what's in front of n is a positive. That's going to give us a negative n. And there you have a negative n, right? And then what is a negative times a positive? Because that one is positive, it's a negative. That's why you've got a negative 1. And then we have a positive 1, which is part of the formula. Okay, so now what is 2n minus n? It's n. And what is minus 1 plus 1? They basically cancel each other out. Okay, so what is the answer? N. How many terms do we have? N terms. See how easy that is? Okay, so quickly, example number 15. So it says expand and calculate, and then we've got a sum there. We've got 12 at the top, 3 at the bottom, and then 6 on the side. It says the expression next to the sigma is a constant. A constant is a number that stands alone. So what do we do if we have something like this? You see, in the previous sums, we had K, we had M, we had all sorts of stuff. But now, there's nothing. Now, solution. We've got sigma, 12 at the top, 3 at the bottom, and we've just got 6. So what does that equal? That equals 12 at the top, 3 at the bottom, and then 6. And now remember this, they haven't told you that you're supposed to put m there, but what do you know? You need to be substituting something, right? And that something starts at 3, and that something ends at 4. Do you see that? I mean, it ends at 12, sorry. It ends at 12. So because we do not have excuse me, because we do not have a letter or an alphabet, a letter of the alphabet, yes, we're going to use what we have at the bottom. And because the numbers are constant, so let me just show you something. And you guys would remember that anything to the power of 0 is 1, right? So what difference does it make for me to have 6m to the power of 0? It's still 6. So how is it still 6? I'm gonna do this so that you don't mix it up. It's because 6 times m to the power of 0 is 6 times 1. Remember, any number that's to the power of 0 equals 1. So 6 times 1 is 6. And so that's how we get our answer. Let's see. Excuse me. So that's our very first one. That's basically our general term. Excuse me. That's our general term. And then we now have to substitute our very first number. Our very first number is 3. And so the next number is 4. And then the next number is 5. Do you see what's changing? So you're not going to change the power of 0. You need to change the number that you're supposed to be substituting in. So in a place of m, that's where you're substituting. Okay. And then because it ends at 12, I mean, if something had to end at 20, would you write a whole line full? No, definitely not. And that's why we have series. And that's why we also have sequences, so that we can calculate what we need to calculate without having to use all the space and all the time. Okay, now we've got 6 times 3 to the power of 0. What is anything to the power of 0? It is 1. And that's why we've got 6 for the first one. There it is. What is 4 to the power of 0? It is 1. And that's why we've got 6 again. And what is 5 to the power of 0? The second last one. It's 1. And so 6 times 1 is 6. And so we've got a whole pattern of 6s, because we have 6 times 1 repeatedly. The very last one is 6 times 12 to the power of 0. So 12 to the power of 0, anything to the power of 0 is 1. And so that's also a 6. Now, how are we going to get the number of terms? This is very important, because if you had an ending of 100, you'd have to know this. It is important. It's vital. It's vital. And so number of terms. So we've got now top, which is 12, minus bottom, which is 3, plus 1. So what is top? 12 minus 3, that is 9. 9 plus 1 is 10. And so we've got a recurring number. We've got 6 that is going to be added 10 times. So what is our answer? What is our sum? Our sum is 6 times the number of terms. Do you see that? 6 times the number of terms. And we figured out that the number of terms is 10. And so 6 times 10 equals 60. 6 times 10 equals 60. And so just go over and over and over it again so that it will make sense to you. And that's about it for today. Thank you.